In this example, we're going to talk about the energy or power generation in a wind farm. So as we know, wind turbines are normally arranged into several wind turbines in a specific land area. This in turn make up a wind farm that generates vast amounts of electricity to provide for energy in communities and in many households. So in this example, a wind farm is constructed from turbines with a rotor diameter of 50 meters and 40% efficiency that are spaced at a distance of 500 meters apart in the prevailing downwind direction and 150 meters apart in the crosswind direction. In a wind of a velocity of 10 meters per second, what is the output of the wind farm per square kilometer? So the question now is the overall power output, okay, power output of a wind farm per square kilometer. So as we all know, the wind turbine has to be arranged in a specific distance from each other so that it can generate maximum power or energy, because it needs wind, so there must be a good spacing between the two. So in this case, if we have a wind turbine, so for example, this is a wind turbine, all right, and the diameter of this wind turbine is given as 50 meters. So we are going to arrange these wind turbines into different areas, okay? So let's say this one. So this part here is 150 meters, and this part here is 500 meters. So as we all know from prevailing wind direction, so if we have downwind direction of 10 meters per second, so this is wind here. So the wind turbine, so we have one wind turbine for this specific area. So this area here, we have only one wind turbine for that. So one wind turbine and another wind turbine here, for example. So for these two areas, we have only two wind turbines, as indicated in these red dots here. Okay, and the question is how much is the power output of the wind farm per square kilometer? All right, question is per square kilometer. So we need to identify first how many wind turbines are there. So number of wind turbines per square kilometer, and then we also need to know the power of each wind turbine, right? So that we can know how much is the overall power of the wind farm. So let's just list down first all the given here. So the diameter of the wind turbine is 50 meters. Efficiency is 40%, which is equal to 0.40. And the distance of each wind turbine, or for one wind turbine, the area of one wind turbine. So this is diameter here. So area, each area occupied. So this is area occupied. So I'll just put occupied. For each turbine is 500 meter times 150 meter, which is equal to 0.5 kilometer times 0.150 kilometer. Because as we all know, 1 kilometer is equal to 1,000 meters. So this one will result to 0.075 square kilometer. So this is now the area occupied by each turbine. So this is basically this part here. All right. So as I mentioned earlier, the steps to take. So what are the steps to take in order to find? Okay, I forgot to put a find. What is we are going to find here? So what we are supposed to do to calculate is the total combined power. Combined power. So what is this one? So this must be in terms of megawatts per square kilometer, or megawatts in terms of power, but in terms of per unit area. Okay, so solution. So what are the steps that we need to do first? In order to get this total power combined, step 1 is the calculate the power of each turbine. Okay, once we have the power of each turbine, calculate the number of turbines per square kilometer. How many turbines are there in 1 square kilometer? And then the third one is to calculate the total combined power for the wind farm. Alright? So there are 3 steps that we are going to do now in order to solve this problem. So let's start with step 1. Okay, so let's continue. For step 1, so we need to find the power for each turbine. Power for each turbine. So what is the formula for that? So we have power is equal to 6.0602 kilogram per cubic meter times the efficiency times the area times the cube of the velocity. And so everything is given here now. So we have the efficiency, area we can calculate, and the velocity is there as well. So first we calculate the area of the turbine, which is pi d squared over 4. So pi and diameter is given as 50 meters squared over 4 is equal to 1,963 square meters. So this is the area now. So we can calculate the power of each turbine, which is 0.602 kilogram per cubic meter times efficiency of 0.4 or 40% times 1,963 square meter times the velocity of 10 meter per second cube. And so the power for each turbine is now 4.73 times 10 to the 5th watts per turbine. Okay, so we have this one as the power. So the next step is to identify or calculate the number of turbines per square kilometer. So how do we do that? In 1 square kilometer, how many turbines are there? So as we all know, we have calculated before, the area occupied by each turbine is given. All right, so we have A here is equal to 0.5 kilometer, which we already calculated before, is equal to 0.075 square kilometer. So that is one turbine needs 0.075 square kilometer of area. So for 1 square kilometer of area, we can now calculate the number of turbines. Number of turbines means equal to 1 square kilometer divided by 0.075 square kilometer per turbine. Right? So we can have the number of turbines in this case is 13.3 turbines. Of course, in reality, we cannot have a fraction of the turbines, but this is only considering 1 square kilometer. So how does it look like actually? So if we try to make it into schematic here in a drawing. All right, so if we have this as 1 square kilometer. So this is 1 kilometer, and this is 1 kilometer. So this is not in scale, but let's say it's like that. And we have as this part is 500 meters, of course, 500 meters, and then we also have 150, right? So let's say this is 500 meters, 150 is like here. So 150, like that. Like for example, that's 150. So this is 150, 150, 150 here, 150, and then so this is 300 here, 300, 300, so 900. So this is 100 here. Okay, so that's 1 kilometer. So as I mentioned before, the distance between in downwind direction is 500 and in upwind is 150. So we have only one of the turbine in each of this area. So we have one turbine there, one here, one here, one, also below. And so of course, in this area here, this is only 100. All right, so we can combine, and so we can have another one. So in this is 200 here, this is 100, this is 100, so 200. So we can have another one turbine there if we want to extend. So how many are these? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 12, 13. So it basically it is correct. So we have 13.3 turbines in 1 square kilometer. So this is 1 square kilometer of area. All right. So that's correct now. So let's try to compute now the total combined power for the wind farm. Okay, so in order to do that, we already have the the power of each turbine. So we can have total power is equal to power of each turbine times the number of turbines. Okay, so we have 4.73 times 10 to the 5th watts and per turbine times 13.3 turbines. Okay, so the answer for this is 6.31 megawatts. And so this is actually in the kilometer, so this is per square kilometer. So the total power is now, the answer is 6.31 megawatts per square kilometer. All right, so this is an example showing to you how to calculate the overall power in a wind farm. So take note that the distance between each turbine is important. So as I've shown here, the distance between this turbine and this turbine is important. So basically this distance is still 500 here. All right, and this distance and this distance is still 150. Okay, so that is the calculation for a wind farm.